Look at these ratios: sine theta, cos theta, tan theta. The values of sine theta, cos theta and tan theta for different values of theta we wrote here. Look at the values of theta that we have taken in this table. The values of theta that we have taken in this table are between 0 degrees and 90 degrees. So only for acute angle, only for angles less than 90 degrees, we wrote down values of sine theta, cos theta, tan theta. Okay. So look at all the angles that we have taken: 0 degrees, 30 degrees, 45 degrees, 60 degrees. All these angles are less than 90 degrees. Look at the first ratio, sine theta. If you look at sine theta, look at how sine theta is changing as angle is changing. As theta increases from 0 degrees to 30 degrees, sine theta increases from 0 to half. As theta increases from 30 degrees to 45 degrees, sine theta increases from half to 1 by root 2. When we increase the angle further to 60 degrees, sine theta value increases to root 3 by 2, and when you increase the angle to 90 degrees, sine theta value increases to 1. So between 0 degrees and 90 degrees, as the value of theta increases, sine theta also increases. Sine theta value increases from 0 to 1. Also from the table, look at the values of cos theta. Cos theta for angle 0 degrees, cos 0 is 1. And from 1, its value decreases to root 3 by 2 when angle increases to 30 degrees. And again, when angle is increased further to 45 degrees, cos theta value decreases to 1 by root 2 and decreases to 1 by 2 for 60 degrees and becomes 0 when theta becomes 90 degrees. So between 0 degrees and 90 degrees, as theta increases, sine theta value increases from 0 to 1 and cos theta value increases from 1 to 0. Also look at tan theta. Tan theta value increases from 0 to infinity. As theta increases from 0 degrees to 90 degrees, tan theta value increases from 0 to infinity. So this is how the ratios sine theta, cos theta, tan theta are changing as theta is changing between 0 degrees and 90 degrees. So what happens for angles greater than 90 degrees? What happens for angles greater than 180 degrees, for greater than 270 degrees? So those angles we will discuss now. Let's look at theta between 0 degrees and 90 degrees again. So we are going to discuss 4 cases. The first case is theta between 0 degrees and 90 degrees. The second case between 90 and 180 degrees. The third case between 180 and 270 degrees. And fourth case between 270 degrees and 360 degrees. So in a circle, you can say there are 4 quadrants of the circle. If you look at a circle here, let me draw a circle. Look at this circle. On this circle, let's show the two axes here, x-axis and y-axis, passing through the center of the circle. Center of the circle is at origin. Let me say this point is O. So angle made by a line with x-axis, if I say, is an angle theta. So this angle is 90 degrees or pi by 2 radians. This angle is 180 degrees or pi radians. Pi by 2 radians means 90 degrees. So from 0 degrees to 90 degrees it is first quadrant. From 90 degrees to 180 degrees it is second quadrant. And if you look at the third quadrant, so with positive x-axis, this angle is 270 degrees. And you know this angle is 180 degrees. So third quadrant in the circle is between 180 degrees and 270 degrees. And you know the total angle in the circle is 360 degrees. So here fourth quadrant means between 270 degrees and 360 degrees. So from 0 degrees to 90 degrees means first quadrant. From 90 degrees to 180 degrees means second quadrant. From 180 degrees to 270 degrees means the third quadrant of the circle. And 270 degrees to 360 degrees means fourth quadrant of the circle. So these are the four cases we are going to discuss. So what happens if angle theta lies between 0 degrees and 90 degrees? That is the first case. And in the second case, between 90 degrees and 180 degrees, it means the second quadrant. The third case is between 180 degrees and 270 degrees. So that's the third quadrant. So again, between 270 and 360 degrees. So this is what we are going to discuss. So let's look at the first case. So take a right angled triangle inside a circle. It's easy to understand what happens to the ratio of sides when you look at a right angled triangle inside a circle. For that we draw a unit circle. Unit circle means a circle with radius equal to 1 unit. So between 0 degrees and 90 degrees, first we will study sine theta, and in the second case again sine theta, in the third case again sine theta, third quadrant, fourth quadrant also sine theta. Again we will go for cos theta. So like that we will see all the three ratios. So first we are going to study what happens to the values of sine theta in the first case or in the first quadrant of the unit circle that we are going to draw. So let's draw a circle here. Look at this circle. Now in this circle, let's say we have an x-axis and y-axis. The center of the circle lies at origin of the coordinate system. Now draw a right angled triangle in the first quadrant of the circle. Let us say this vertex of the right angled triangle is A and this vertex of the right angled triangle is B. Now angle made by the hypotenuse with x-axis is, let's say, angle theta. Adjacent side to angle theta is along x-axis, so OA, let's give the symbol x, the usual symbol. Let's give the symbol to the vertical line y, and this R is hypotenuse and also radius of the circle. Since this is assumed to be a unit circle, radius is equal to 1 unit. Now, let me call this angle here as alpha, angle A in the right angle triangle is 90 degrees. As you can see, alpha plus theta is equal to 90 degrees because this third angle is 90 degrees. Sum of the angles in a triangle is 180 degrees. So alpha plus theta is equal to 90 degrees. Or we can write alpha is equal to 90 degrees minus theta. This we have already seen in our discussion, but let's look at it again. Look at theta. Sin theta is equal to y by r. As theta increases, y increases, r is equal to 1 unit. As theta increases, y increases, hence sin theta also increases. We have already written as theta increases from 0 degrees to 90 degrees, sin theta increases from the value 0 to 1. Theta is increasing, sin theta is also increasing because this opposite side keeps increasing. We have seen that already anyway. And look at the figure. If you look at the figure, cos theta you can say is x by r, cos theta is equal to x by r. Sin alpha is equal to, what is sin alpha equal to? Opposite side by adjacent side, opposite to angle alpha. Sin alpha is equal to opposite side by hypotenuse, not opposite side by adjacent side. So sin alpha is equal to x by r. Opposite side of the angle alpha is x and r is hypotenuse. Sin alpha is equal to x by r. Substitute alpha is equal to 90 degrees minus theta here. You will get sin 90 degrees minus theta. Substitute x by r is equal to cos theta here. If you substitute x by r is equal to cos theta, you will get sin 90 degrees minus theta is equal to cos theta. So this is one of the trigonometric identities that we have to keep in mind. So in the first quadrant, that is when angle is between 0 degrees and 90 degrees, we have come to two conclusions about sin theta. One conclusion is that as theta increases from 0 degrees to 90 degrees, sin theta value increases from 0 to 1. And sin 90 degrees minus theta is equal to cos theta. We have seen for in this quadrant x is positive, y is also positive, that is why sin theta values are positive. Here this is a positive x direction, positive x axis, y is measured above x axis, so y is positive, r is anyway positive, r is equal to 1. So sin theta values, all values of sin theta are positive in this quadrant. Okay, and all values of sin theta lie between 0 and 1. All values of sin theta lie between 0 and 1. It means sin theta values are positive. So sin theta is positive and increasing. As theta is increasing from 0 degrees to 90 degrees. And this is the second conclusion that we have come to. Let's call this first equation. We'll write all those such equations at one place later.